Next, I want to talk about climate change and start with just like a broad overview. So the first thing to kind of talk about is that climates change over time, and they change for natural reasons and also for human influenced reasons. So we're going to talk about the climates of the past. How do we learn about climates that have happened in prehistory, like ice ages, warm periods, warm periods back when the dinosaurs were around, and what are some of the natural causes of climate change. And we'll also talk a little bit about future climates, and particularly anthropogenic or human influenced climate change as well. So let's start by looking at some of the climates of the past. That there are long-term changes that happen over long periods of time that we can look at. So we've talked about the concept of scale, like spatial scale. We can also consider temporal scale, like time scale. So if we're looking at how climates have changed, it kind of depends on the time scale we're looking at. If we're looking at over, like back to the time of the dinosaurs, back when there were dinosaurs, like millions of years ago, it was actually warmer on Earth than it is today. And so there's been a general cooling trend. Now, if we look at hundreds of thousands of years, then things look a little bit different. We had generally a lot of very cold periods. These are the ice ages with until about 10,000 years ago, when our climate became more stable and warm. And if we're looking at hundreds of years, then we see a different pattern. We see a fairly consistent and stable warm climate with very recent warming when you hear that people talk about human climate change, this is that signal that they're talking about there. So we're going to kind of talk about all of these in general. Here's a closer view of this. And now, how do we know the climate has changed in the past? Well, it's because we use things in nature to tell us, and I'm going to go over that separately. But using things in nature like tree rings or ocean sediments and things like that, we can kind of get a general sense of how things have changed, although not perfectly like weather stations, but we can get a general sense of how the climate has changed over long periods of time, shorter periods of time, and even shorter periods of time, including modern weather records going back a couple hundred years, or some cases longer. Now, I want to kind of highlight this figure here. This is kind of going back a little over 100,000 years, and kind of zooming in on this part where we have this split between what's happening up to 10,000 years ago and what was happening prior to 10,000 years ago. Prior to 10,000 years ago, we were in a period called the Pleistocene. Then if you look at this chart, you'll notice that you have all these dips here. And what this chart is showing is dips that are ice ages. And the Holocene here, this modern period, about 10,000 years, you see a little bit of dipping, but not as nearly as deep as the previous 100,000 years or so. And this is called the Holocene. And if you think about ancient civilizations, Egyptians, Mesopotamians, and all the kind of human history that we've talked about as far as civilizations or whatever, it's all kind of packed into this Holocene period. The humans have been around further back, but it wasn't until this modern warm period when we domesticated plants, had agriculture, built cities, and then a lot of the other things that you learn about in history class. So I want you to kind of know these. Now we're going to be talking about these in the future as well, especially when we talk about glaciers and topics like that. Sea level change. You have the Pleistocene, or the ice ages, that go back about 2.5 million years until about 10,000 years ago. And so the Pleistocene is the ice ages, when we had, the Earth really cooled down. We had ice covering a third of the Earth. And then we have this more modern 10,000 year period, roughly, of the Holocene, where we haven't had these dramatic ice ages, and our climate has been more warmer and stable. So these are some kind of recreations of North America before the Pleistocene, before the ice ages during the warmer period. A couple things I'll point out. This white color is like shallow sea. So you have lots of Florida underwater, the Central Valley underwater, because this is a warmer period and there's more water in the oceans and less ice. And when we get into the Pleistocene or the ice ages, now this white appears a huge ice sheet that's covering North America and part of Europe. Because there's more water on the land as ice, there's less water in the ocean, sea levels are lower. Florida is now out of the water, as well as California, even more so than it is today. Where San Francisco Bay is today, it would have been just a river valley and the coast would have been further offshore. Then as that ice melts, water goes back into the ocean, and you kind of have the environment that we have today. Now, one thing I'll note is if we kind of go through these again, we start from before the ice ages, and then we move to today, you can see where the ice was, it radically changed the landscape. And we're going to talk more about that later in the semester, about how the ice reshaped the landscape. For right now, we're talking just more about the climate in general, and also about changes in sea level. We're going to be covering that as well. So as we move from the ice ages into the Holocene, sea levels have risen as that ice melted, because as it melts, where's the water go? Into the ocean. And we've covered this before, so I want to just review this really quick. Recall the green, we've talked about electromagnetic energy and how the sun is hotter, so it has shortwave energy, and the earth is cooler and it emits longer wave energy. All right, so we have a shortwave, high powerful energy from the sun, shorter wavelength. Because the sun is hotter, it warms the earth, and then the earth in return balances that out through the emission of terrestrial radiation, long wave energy. And we've also covered the greenhouse effect. So the greenhouse effect is about slowing down some of that long wave energy that the earth is emitting, and it kind of slows it down as it's a space. And we talked about the two primary greenhouse gases, carbon dioxide and water vapor. Now when we talk about human influenced climate change, I'm not going to worry so much about water vapor because humans are not emitting water vapor. We are going to focus a little bit on carbon dioxide. If you recall, that's what that Mauna Loa curve is about carbon dioxide measurements in Hawaii at the Mauna Loa Observatory. It fluctuates up and down. That's because of the seasons. But there's also this increasing trend in carbon dioxide level. Also, this is called the Keeling curve. I'm going to include a video that talks about Keeling and this experiment and how people how people developed and understood this information. Now, what's important about the Keeling curve is that starting in the late 1950s, this is where people started to have an understanding of how much carbon dioxide there really was. Before that, people didn't have good measurements of it. People didn't know how much there is in the atmosphere, how much there should be. People understood the greenhouse effect and what carbon dioxide does. What they didn't know is how much is there and what the trends were over time. So this experiment helped to kind of show these trends. Now, at first, they were kind of concerned about their results because it fluctuated up and down each year. But what that was is that there's an imbalance in how many trees there are in the north of the earth versus the south. And as all these trees grow green, they suck up carbon dioxide, the levels go down. And then as they senesce or go back, they're not growing, the levels go back up. And that's why you have these kind of, why it looks jumpy, you have that kind of up and down seesaw level. However, the more alarming trend is that while it goes up and down over the course of the year, over many years, when you look at it, it's going up. There's sort of this upward direction. So this is a more recent one. Carbon dioxide levels now are past the 400 mark. I think in the previous lecture I used an old figure where it was not quite there, but it's continuing to go up. Now, so what we have is an understanding that from the late 1950s until today, carbon dioxide levels are going up. But what we don't really understand is, well, what's happening before 1958, right? So what scientists had to do to put this trend here in context is to go out and find some way to try to understand carbon dioxide levels going further into the past, right? And then that can help put into context how this fits with natural trends over over long periods of time. Then after that, what we're going to look at is scientists have to find a way to try to estimate what these trends are going to look at going forward in time. So we're going to look at the past, and then we're going to look also at the potential future.